In any election, the numbers are supposed to tell a clear story. But what happens when they don't? What if they tell a story that seems almost impossible? Today, we're going to dive into the 2024 Andhra Pradesh election, where a truly record-breaking voter turnout has raised some serious questions about, well, simple math, and the limits of time itself. So here's where it all kicks off, the official announcement from the Chief Electoral Officer of Andhra Pradesh. A massive, staggering 81.86% voter turnout. It was celebrated as this huge success, the highest in the country's general elections at that point. This was the triumphant official story. All right, first things first, let's get that official number locked in, because this celebrated figure, this is the baseline for everything that's about to follow. And just so we're all on the same page, voter turnout is pretty simple, right? It's just the percentage of people who are eligible to vote who actually showed up and cast their ballot. A simple metric that, believe me, in this case, tells one heck of a complex story. So this is the big number everyone was talking about, 81.86%. When you include postal ballots, we're talking over 33.8 million people. That's undeniably impressive. But look, the real story here isn't just that final number. It's the journey. It's how we got there. And this is where things start to get a little weird. See, that final number, it wasn't just announced once. It trickled out in stages. And when you look at the timeline of those announcements, you start to see a pattern that just feels off. Just take a look at this timeline from polling day, May 13th. At 5 p.m., turnout is sitting at 68%. Okay? 3 hours later, at 8 p.m., it's barely moved at all. But then, boom, look what happens. In the next few hours, it skyrockets by over 8%. And even then, it gets revised up again a few days later. Now, what's so wild about this chart is it shows you the speed of the increase. See that tiny little bar between 5 and 8 p.m.? That's just 33,000 votes. But the bar right next to it? Whoa. That represents a massive surge of nearly 3.5 million votes pouring in before midnight. That late-night rush is what we really need to dig into. So what on earth could explain a massive surge like that well after polling stations were supposed to be closed? Let's actually quantify it. Let's figure out what it would physically take to process that many people that late into the night. Okay, so the official reason came straight from the Chief Electoral Officer. He said that at almost midnight, 3,500 polling booths were still open because people were still waiting in line to vote. And that number, 3,500 booths, you gotta remember that. It's the key to this whole puzzle. So, when you do the math on the final numbers, you get this. This is how many votes were added to the total after that 11:45 p.m. update. We're talking more than 1.7 million votes, all supposedly cast in just those 3,500 booths. And this table really breaks it down for you. You take those 1.7 million late-night votes, you divide them by the 3,500 booths that were still open, and you get an average of 491 people who still had to vote in each one of those locations after almost midnight. And here's the real kicker. The CEO gave a hard deadline. He went on record saying all polling was done by 2 a.m. So that gives us a very specific window, just 2 hours and 15 minutes to process all 491 of those voters in every single one of those booths. The question is that even possible? I mean, physically possible? All right, this is where we get to the heart of the whole thing. Let's calculate the exact time available for each voter and see if it actually lines up with the physical reality of how you vote. First off, you gotta remember, people weren't just casting one vote. Andhra Pradesh had 2 elections happening at once, one for the state assembly, one for the national parliament. So as you see here, every single voter had to get their ID checked, get their finger inked, and then go cast 2 separate votes on 2 different machines. Okay, but here's the thing. There's a part of this process you just can't speed up. It's a hard-coded delay. After each vote you cast, it takes 7 seconds for the VV paypad slip, that's the little paper receipt, to print. And since everyone cast 2 votes, that's a built-in, non-negotiable delay of 14 seconds for the machine is just busy. Nothing else can happen. So let's put it all together. Here's the ultimate challenge. Can you really shove 491 people through that entire multi-step, 2-ballot process in just 135 minutes? Let's do the math. And the answer you get, well, it's pretty mind-blowing. It comes out to just 17 seconds per voter. That's it. 17 seconds for the entire thing. Check the ID, ink the finger, walk to the first machine, vote. Wait, walk to the second machine, vote, wait again, and get out.
And this slide just lays it all out, plain and simple. Out of the total 17 seconds available for each person, we know for a fact that 14 of those seconds are automatically eaten up by the machine just printing the paper slips. That leaves, wait for it, 3 seconds. 3 seconds for a human being to do everything else. The source material argues this isn't just unlikely, it's a physical impossibility. So look, this whole breakdown doesn't give us a smoking gun. What it does is leave us with some really big questions that, according to the source material, only the election authorities can actually answer.
Now, the cool thing is, the system is actually built for this. There are ways to check. The rules say you have to give out serialized tokens to voters still in line, that the queues have to be video recorded, and that the officer in charge of each booth keeps a super detailed diary. All of this evidence should exist somewhere. Which brings us to the one big question the source material leaves hanging in the air. Given how mathematically improbable this all seems, will the Election Commission of India open up its records and explain just how this extraordinary, record-breaking feat was actually achieved? It's a question that, for right now, is still unanswered.